Hello everybody, welcome to a session about Akamai and what Akamai is going to do in the space of IoT. We are going to focus mainly on an aspect which is called OTA, and we are going to try to combine that with some common third-party solutions like Google Sheet. I tried to divide that presentation into certain topics. The topics I choose to has been IoT, OTA in that case, over the air, and Akamai. Another topic which we are going to talk about is Mozart in Google Sheet, which I hope is a little bit of fun for everybody. And the last topic is Bosch IoT device management. The second topic can also be called Akamai OTA and Google Sheet, so that's maybe not that confusing for everybody. Let's start. When we talk about IoT, OTA, and Akamai, I think it's important to make clear what's my interpretation of IoT here. So I'm trying to give you a little bit of my interpretation of IoT. So if I talk about Internet of Things, which IoT stands for, then I like to talk about smart devices. And maybe you're asking yourself what smart devices means. Let me give you an example for that one. So let's assume we have a stove. Maybe you know that from your kitchen. And let's assume we add the hand to the picture. And now let's assume that we heat up one of the plates, and maybe you know what's coming next. If we would now touch that hot plate with our finger, what happens is, sure, you know it already, it hurts. And the point is, what I'm trying to say is there's something involved that is called nerve cells. And nerve cells, if you look at the whole event chain, is something what comes from the hand, from your skin to be more precisely, goes through the nerve cells to your brain. And the thing what we should learn out of it, which makes us smarter next time, is something what people like to call a feedback loop. And so means we now should have a rule in our brain which tells us do not touch a hot plate, hopefully. If we take that back to IoT devices, what it means on IoT devices is there will be some kind of devices out there which will have something what is called a sensor. That's quite common in the IoT space. And that sensor will be able to react on a certain event. And it will be able to send that information over to something like a brain. Reality shows that we don't have brains and data center. Instead, we have application servers which are going to do that work for us. And we need somehow to send that information over. What happens on the application server is that he will start to think about that event. And he will hopefully come to the conclusion, which is a new rule, that that's something that should be avoided in the future. And the next step would be to send that information back to the device. That's what we call an update. And that's what is called OTA in my interpretation, and that's something where Akamai can help. We expect to see a lot of events, to be honest, and therefore we expect to see a lot of things to learn for such IoT devices. The beautiness of IoT devices here is that hopefully they will learn every lesson only once. That makes it so powerful, and I think that is one of the reasons why IoT got so much attraction. It could mean at the end of the day that your coffee machine is telling you the coffee is ready. But to take a more real-life example, I'm going to talk about something what is called smart traffic lights. That's something what certain car manufacturers are going to offer or offer already, to be honest. And the idea behind this, to explain that a little bit, is if you're driving your car on the street, then chances are that you're going to cross some traffic lights. And if you cross the traffic lights, you have to know that the traffic lights are managed by a so-called traffic information system. That traffic information system gets the state of the traffic lights and controls and manages the traffic lights. If a car manufacturer likes to offer something what we call smart traffic light, then what he needs to do first, he needs to retrieve the data from that traffic information system, the states of all the traffic lights which he is interested on. That traffic light system are most of the time per city. They are all coming in different implementations. Some of them are quite new, some of them are quite old. In that case here, we have been told that one traffic light information system they have been working with did have the need that they created 8,000 SSL requests per second, short-living SSL connection. That's huge if you think about that. That's just two systems which are talking to each other, and they have, per second, they have to create 8,000 short-living SSL connection. On the other side, if a car manufacturer would like to offer such a service to his car, he needs also to have some kind of connection to the car. It means in that case that whenever a car starts up in the morning, if you drive your car in the morning when you drive from home to work, then your car will need to get updates about where the traffic lights are located. Because think about it, if roadworks did happen, then maybe new traffic lights that have been set up, or maybe some have been dismounted. So there's a need also for the car manufacturer to send that kind of data down to you, map data which contains information about traffic light. If now the car comes close to a traffic light, then what the car does, it starts to communicate with the data center of the OEM, the car manufacturer. It asks for the state of the traffic light. The reason why it does that is it tries to tell you on your cockpit display how far away you are, how many seconds it will take before the traffic light will switch. And you can take the decision to say, am I going to accelerate to go over it, or am I going to slow down, to stop? It helps you to drive more efficient. By the way, that will also be used by automated cars later on. They will do that by their own. They will decide for you. So something like that would look like this here. It's not really easy to see, but the point I'm trying to make here is that they use it for 2 cities, and both cities together consume at a monthly base 8.5 terabytes of data. So I believe and this is the whole scenario which we see here, there's a good fit for Akamai here, because Akamai has this capability to support such massive amount of data and requests. And in our case, we are talking about OTA here. So we will see downloads, something what we do already for ages, which can be supported by us. But such amount of data needs also to be transferred from the car to the data center somewhere. And most of the time, you will see that these cars are using good cellular connection. So the point about, is it really a good cellular connection or not? So is it challenging to use cellular connection or not? So I tried to find some good statistics which shows how good cellular connection is doing. I found that by looking at a company which is called PacketZoom, and they have a nice report which everybody can see on their homepage. And if you look at that report, it shows you for all kinds of different cellular network technologies, the package loss around the divided by countries. And you can see, maybe you don't know that, or maybe you know that, based on Google, for a fixed line internet connection, you have on a global base, you have an average of 2% package loss. And you can see here package loss depending on the technology which you are using, which are around 6 or 5%. And even in markets which are really important, like China, and that's an important market for car manufacturer. What I'm trying to say is that if you have to expect that you have a lot of data, that you have maybe connections which are not that good, then maybe time becomes critical. So the question is time a critical aspect for your OTA service if you like to update your cars? Let's take a step back and think about how long does a car drive on the street, because you have to know that only cars which are not e-cars have this requirement that they can only connect to the internet when they are driving. When they are not driving, they cannot connect. The reason, therefore, is there's a chance to consume the whole battery, and that's something what car manufacturer needs to avoid. So it means energy management plays an important role here. So it means what's your time window when you are driving only? So coming back to the connected cars example, I took a study done by the European Union, which shows that in Europe, based per country, and an average, every car is driven 2 hours a day. And in addition to that one, it does 2 trips a day, which makes a lot of sense for me, because if you think about it, at the morning you drive from home to work, and at the evening you drive from work to home. So if you make some simple maths, we come up with a number which is 1 hour per download window, to say like that. So you could assume that 1 hour sounds not too bad. You know, maybe it's a lot of data which you have to download. Maybe you know that connectivity is not that good. Then there's maybe another aspect which needs to be considered here, and that is most of the time when you are commuting, other people are commuting with you too. So it means radio station or mobile networks are separated in cells, and if that cells gets rowdy, that brings down your download rate in addition. So there's quite a challenge maybe to always get all the cars updated in such situation. To bring it to the point with, to make it a little bit more clear, why should I be so concerned about if my car gets updated or not? Think about a scenario in which your car, maybe you as a car manufacturer or any IoT device, gets the information that somebody did find a way to hack into your device. Let's assume somebody did create an app which allows them remotely open your car doors. So, and he posts that to everybody who is interested. Then you would like, if you detect something like that, you would like to fix it, and if you fix it, you would like to update that. So, which means learn a new rule to avoid that situation. And you would like to keep the whole thing as short as possible, because that means that you will not have that much issue with your customers. And there are real cases like that where we have seen that. There are some of them. And what I'm trying to say is that if you put Akamai OTA into the game, then chances are that you can reduce one of these aspects by ensuring that the downloads, when they start to happen, the updates, when they start to happen, that on the network side, you can be sure that things will be downloaded to the cars, in our example. Conclusion number one, which I like to make here, is that we are going to face large data volume in the IoT space, especially if we look at cars. We are going to face time-critical situation, and we will have situations which are where we need to ensure that everything is secure. And honestly, there are three things in which Akamai is really good, and I think there's a real space for us to be here, and that's the reason why Akamai will launch today a product which is called OTA. There will be on our closure keynote today, there will be talked about that. You can also find already information about it on our website if you like. But let's now take one step back. We talked about OTA. How does Akamai in general fit in the IoT space, in an IoT architecture? Because I think that's just the first step which we are doing. We are considering to do more. But let me give you a short overview about what's my interpretation of an IoT infrastructure or architecture, to be more clear here. So an IoT architecture in my case means we have a lot of sensors, and there are all kinds of sensors, and we like to collect that information. That's where we talk about the database where we have to store that information. Then in addition to that, we need an infrastructure via which we can collect that data. That means either the normal internet like you know it, based on TCP, or even things like LoRa, which is based on a complete different frequency. But in addition to that one, we also need the possibility to process that data so that we can learn something out of it, some new rules. And if we do that, we need also a so-called deployment management application, which allows us to package that new lesson which we learned. And for sure, we need somewhere to store all these new updates. And finally, for sure, we need all the clients which needs to be updated with that, which can be a car, can be a desktop PC, can be a workshop server, it could be anything. And for sure, again, we need an infrastructure via which we can provide that updates to the cars. Bring it back. How does Akamai fit into that one? Let me show you where I believe we have a good place to be. One place where we are really good to be is when it comes to the network. So when you are sending data to your data center, then Akamai is maybe a really good choice. If you have massive data, if you need global scale, then that's a good fit for us. And database side, think about our network. It's not only a network which is doing caching, it can help you even to queue some of your data in case your database gets into struggle because the amount of data is so high. We can help you on that level to say, we hold the data back till you are ready to get more from us. Data processing, our platform is also able to process data. In addition to that one, we have really good interfaces, REST APIs, which can be used by whatever kind of deployment management system you use to remotely control, automated the Akamai platform. So it means the integration with Akamai shouldn't be that difficult. I will show you later an example of that one. File storage. Maybe you know that Akamai offers persistent storages which replicate around the globe with several locations, if you like. And that's also a possibility where you could store your updates if you like them to be globally available on a persistent base. And for sure, our network, like you know it already from before, via which you can download data with a high scale on a global base. And something what is also quite interesting, we have a mobile SDK, which also has functionalities like a download manager, which could be used, if you like, to ensure that download happens via the network in a good way. So it contains several functionalities which are really nice. If you are interested about that, we can go into detail afterwards. So my second conclusion, which I'm going to do here, is that I think we have with Akamai a high potential to be a good player inside that IoT space because of all the things which are needed there, or which we see which will be needed and what our customer tells us. Now I would like to go over to the next point, and that's Akamai OTA and Google Sheet. The whole intention here is to give you just a little bit of an insight about what are the capabilities of the new OTA service. So therefore, I would like to explain first, or let me say the other way around, do you like Mozart? Does anybody like Mozart here? Perfect. Me too. There's a guy who is called Günther Niemetz. He's from the University of Köln. And he did manage to transfer the Mozart Symphony number 40 with 4.7 times the speed of light, which is really impressive to be honest. So in my demo today, I'm not going to transfer the data with that velocity, but I still think that we will see some really good performance numbers. But more important, I would like to explain first the setup and try to explain what exactly makes OTA so special, or one of the aspects which I believe makes it to be a great tool. And for sure, we are going to download the MP3. We are going to use Akamai OTA to provide the MP3 file to all our devices. Call it cars. I'm calling them for now clients. Therefore, we are going to put our MP3 file on net storage. And then we are using one of our components which comes with Akamai OTA service, which is called HIP binding. There's a lot to tell about that, but because that's not the focus of this talk, my focus is much more about how that whole service can be accessed or managed via the Akamai Open API, where I'm going to use Java. I'm not going into detail on the HIP binding part. But if you are interested, that's a really great module which is included. We can have a talk afterwards. What I would like to present more today is the reporting capability which comes with the OTA product. And to do that, I'm going to connect it with Google Sheet. So I'm going to use Google Sheet to retrieve via our reporting API, which comes with the OTA product, in real-time data from the downloads which will be happening. Which downloads are we talking about? I'm going to simulate downloads with our product, which is called Akamai Cloud Test. Therefore, I'm going to have 4 locations around the world. From each location, I'm going to simulate 10 clients, and each of that client will simulate by itself, I think, how many was it? 4 clients, 4 virtual clients. So that should sum up, if I did the maths right, to 1,000 unique devices, which I'm going to simulate. In total, they will download 8.6 gigabyte, and I'm going to show you that all will happen below 1 minute. That's the whole goal of the demo, which we are going to do. The demo is divided into 4 steps. Upload via Akamai Open API to the OTA product, to the OTA service. Test download via curl via the OTA service. And then run the cloud test with 1,000 users from 4 locations around the world, means Asia, Europe, North and South America, and then have a look via Google Sheets on the reports. So let's start with the upload via Akamai Open API. Like I mentioned in my slides, I decided, because our talks, when we ever talk to enterprise customer, is still that they are using Java mainly. Also for their connected cars initiatives, we see a lot of Java being used. So this demo is going to use Java to talk to the Akamai Open API interface of OTA. Therefore, I'm going to a shell, and I did run the interface which we did written for the Akamai OTA service. I put that in the Docker instance. That allows me later on, after the talk is done, after the conference is done, to provide that via Docker if anybody is interested on that one, to play around with that one. So I'm going just to ramp up a Docker instance which runs Java on it. Then I'm going to switch to the folder. Under that folder, I have a jar file, so I'm going to say jar to run Java from the command line. You could use this Open CLI jar file as a library and to use it on program and use it inside your own Java class files, which you are going to program. But just for simplicity, I also implemented the possibility to use a jar file from the command line. So what we are going to do here is we are going to use the flag M, which stands for mode, and we are going to say we like to upload something. And so we need to say what is the input which we would like to upload, and in our case, it's the MP4 file Mozart Symphony 40, so which is shortened to Mozart 40. And we like to upload that to our net storage server. How many of you are familiar with the Akamai net storage service? Okay, a short explanation of the Akamai net storage. That's a persistent file storage, which has some replication. If you use it via an interface, it looks like one simple interface, but reality shows it's more than one net storage, and they are deployed around the world. The nice thing about it, you just manage it as it would be just one single instance, but reality is it's more than one instance, and it has an SLA of 100% uptime, which is really nice. And one thing which is really specific to a net storage is that net storage, you can't upload things to the root folder itself. You will have to use something what is called a CP code folder, which is the case here. And in our case, that CP code folder is called 59907. And afterwards, we can now define an URL. I think what would be a good name is maybe update, maybe the year which we are in, maybe the month. Maybe we should call a model, because maybe we have different devices. So I'm calling that model 1. Then I'm going to say that's release 1. And then I'd like to say I like to upload Mozart 40.mp3. That's what I like to do. So what happens now is the file gets uploaded to that net storage. The net storage takes the file, replicates it to 2 other locations. Currently, we have 3 locations on that net storage, one in US, one in Europe, and one in Asia. And that happens all in the background for me. And I'm just waiting till that's finished. And as soon as that process finished, which it does, I'm going to exit from my Docker instance. And I'm going to do just a quick test. So it means what we did now is we did the upload, and the next step is let's try to test that. Just from my machine, trying to download that file. Let's see what happens if I really can download it already. So I'm using curl. Does everybody know curl? Curl is an interface like a browser, but just on the command shell. So if somebody doesn't know it. So verbose means it makes it a little bit more chatty, which is maybe not a bad thing. Minus uppercase O means he writes on my file disk with the file name, which is after the last slash. And so I'm going to say HTTP. I did set up an OTA configuration, which listens to the hostname OTA edgegate DE. And then for sure, I need to take that part here. So that's the one which I need. Here we go. That's the one. Let's see if I did everything right. 200, it's going to start to download the file. That's just a simple test. So I uploaded it via Java. Now I'm testing via curl if everything works as I expected it to work. And it takes a while, but here we are. And now maybe we should try out if it really plays fine. So RF play, Mozart 40, Mozart 40 MP3. I can't hear anything. Oh. There it should be. So now I need to, let me pull out that one here. Something happened. So the file should be playing, honestly. I don't know why not, but I believe it's something like, yeah, I believe something with the HDMI. Let's see, once again. No, he also killed somehow my audio in general. Yeah, anyway, sorry for that one. I thought we could listen a little bit into nice Mozart music, which is not possible here. What a shame. Okay, let's go on. Later on, I can show you that the file is playing. If I displug the HDMI, you can listen it directly from my machine if you like. Going back to the presentation, now I mentioned to you that I would like to simulate 1,000 users. So, which I haven't done on my request with curl is I need to add a unique identifier. That's something what we do on our cloud test environment. We are going to add an additional parameter to each request to make each client unique so it can be identified by our OTA system, OTA solution. So now let's go on to the next step. I think I should have something prepared here exactly. I don't know if you're familiar with the cloud test service which we provide. I'm not going into much detail here, but I'm trying to get to the idea what I'm going to do here. So it means if you use cloud test, that's a system which is built up to do large performance or load test. It's really nice. I just learned about it because it's quite a new product, even for Akamai. But let's start with it. So the first thing what we need to do is we need to go to composition. Here, my name is Christian Pino Tossi, so I called my composition CPT composition. That's the way how it has to be. And here we can see that's really hard to read maybe. Sorry for that one, but here in general what I did is, let me show you the properties. I defined four locations which should be used to run the test. And in each location, I mentioned to use 10 agents. What I need to do next is, because I just uploaded a new file, I need really to let the system know what's the URL which should be used. So I did some tests before with some other URL names, but they are not the one which we used right now, so I'm going to change that. So now that's the URL which we are going to use, but there's something missing at the beginning. Here we go. I need to save that, which I'm doing right now. And after I'm done with that one, I can start the test. So let's go and start the test. So what happens now is we are going to ramp up some virtual machines. That will take a while, and then at a certain point, that system will switch over to another view in which we can see how we are progressing, how many requests are sent. We will also see how many error happens, if error happens at all, on the download. Here we go. So what you can see here is the time which has been taken so far. We see the amount of message which has been sent. We see the amount of errors. We see the average response time. We see the amount of data which has been so far been downloaded, 5.8 right now. And we expect this number to go up to 1,000. And we expect this number to stay 0. And that one here should go something around 8 gigabytes. And everything should stay under 1 minute if everything works fine. You can see the average response time here. And here we are, close to 1 minute. That was really close. Perfect. So now we uploaded all that data. So here we can see, okay, we did send all that client requests, but how can OTA tell us the same story? So what I did, like mentioned before, I used Google Sheets. So what I did inside Google Sheet, I defined already the same model. I mentioned that there will be 1,000 devices. I need that because I need to tell the system how many devices are going to be handled so that the device can say, okay, you mentioned that you have 1,000 devices. I can tell you I have seen 1,000 unique requests from unique devices, and I can tell you you achieve 100% deployment. So what I need to do here is now I need to click on update. What happens in the background, I'm going to show you that. First of all, what happens is, let me go to tools, script. Where is script editor? Inside script editor, I did just add some, you have to use some kind of JavaScript here, which allows you to connect against the Akamai Open API, and did some additional just to retrieve the data and to visualize them a little bit. That's all I did here. That's also something I'm going to provide later on, so it will be provided via Akamai's pages. I believe I will put it under developer.akamai.com. And yeah, okay, once again, doing that here. And what we should see here, normally, is that we receive the data. So what you see here is he's telling me if he receives the data, so he's trying to retrieve data. And every time I'm clicking on update, he's connecting against the Akamai OTA interface, and he's trying to retrieve the latest state, how many updates have been done. And you can see he tells me what's the delta between my last call I did, and he tells me the current, the start date and the end date of the request, which has been done here. And I'm a little bit surprised that it takes so long. Normally it takes less than 1 minute to retrieve that information from the Akamai OTA interface. Yeah, I tried it several times, so I played with that demo before, I have to say, and it was always below 1 minute before we retrieved the whole data. Let me try to go over to, yeah, I just wanted to show you that report, how it goes. Let me try to have a look at the, that one is finished, looks good, 1,000 messages has been sent, so it should be working, honestly. Maybe let's give it some more baking time, but that's a little bit weird, to be honest, and let's go on to the next topic. So the next topic which I wanted to discuss is, and before I'm going to discuss that, is the point that is Google Sheet an enterprise-ready solution? And that's really an important question to ask. And the point is, I figured out that Google Sheet has some limitations on it, like it can only support 400,000 cells, and if we're talking about a large amount of devices, that's maybe not the right thing to use. So I tried to think about which is a good IoT platform which can be used there for. And so I did a lookup at Google, and there's several IoT platforms which you could use. And I decided to go with Bosch because I'm located in Germany and we have relationships to Bosch. So I chose that one and looked up how it would work with Bosch in that case. So I'm going to give you a quick introduction into how this Bosch IoT solution looks like. It's really simple, and in its core, it contains of two main components. One is the so-called ProSyst gateway software, and that's, at the end of the day, the agent or the client or the sensor, or however you like to call it, and the so-called Bosch IoT Remote Manager. That's a component which tries to manage all the devices. And what we are going to do is we are going to look at this Bosch ProSyst gateway. It contains the possibility to understand a lot of different IoT protocols so that it can talk to all kinds of sensors which it's connected to. And on this other side, it contains this kind of skill engine. I call it skill engine. They call it plugins. And for each plugin, you have something what is called a bundle, which is at the end of the day, this kind of lesson learned thing which we have been talking about. And they can have many of them. And if you like to update that device, most of the time you're going to deploy a new bundle on that one. And that happens by including the Bosch IoT Remote Manager, where the Bosch ProSyst gateway, that's the one on the left-hand side, does have a long-living TCP connection with your Bosch IoT Remote Manager. And you will see that there's a lot of such devices which are trying to connect against your Bosch IoT Remote Manager. How does Akamai OTA fit in here? So let's assume we define a new bundle, then we put it like I did it before on the Akamai platform. And at the other side, at the same time, we need to inform the Bosch IoT Remote Manager about this new update. So we tell the Bosch IoT Manager, hey, there's a new update. Can you tell that to all your devices? And then the Bosch IoT Remote Manager will send that message to all the Bosch IoT devices. And what happens is each of them will come back to the Akamai system and get them. So the only idea behind that picture is to show you that there's no rocket science behind adding Akamai OTA into the game here. What happens at the end is you will see that bundle being added to the skill engine. And so what we are trying to achieve here is to avoid that situation like you see it here, and instead having such a situation, which means better scale, better performance, and good security in addition to that one. A live demo of that Bosch system. Let me see if everything is running. Nope, it's not. I'm going to start the Bosch Remote Manager. Therefore, I need to do SSH into a server, which I'm going to do right now. And after I started it, I will show you just how easy it would be to add the Akamai URL there to get it updated to all the devices, which is really a simple thing to do. So I'm going over to a certain directory, and I have to start the remote manager. And in addition to that one, I will also have to go over and start the web console, the web interface, which we are going to use shortly. So like you can see, he's on the left-hand side, he's already starting several bundles, which he needs. And as soon as he's done, system started, I'm going to start the console web. And after I'm done with that one, it takes also a few seconds. And that's really running on the internet. That message you see here is because he's complaining that the SSH port is already in use. That's the case because I'm SSH into that machine. That's okay. But going back here, I can go over and say, go and access the ProSyst remote manager. Like you can see, you can run that on your own virtual machine. You can run it wherever you like. You can run it even in the cloud. The point I'm trying to make here is whatever you do with it, it will be really easy to tell that system, hey, let all your devices know that they can get all the updates from Akamai. And that's by going to Device Manager. And inside the Device Manager, you should see a list of all your devices which you have added to it. Currently, I just have one device added to that one, and that one is currently offline. But what I'm trying to say is that if you go, you can do that even on that level here if you like. You can say update devices, which I'm now going to do just for the one which I'm having, that one here. So here you can say install bundle. And what you would need to do is just add the URL here, exact that URL you would have to add here with HTTP. I would recommend you use HTTPS here, and then OTA edge gate DE /. And that's all you have to do. And then he will take care to announce that to all the devices which are out there, and they all will go over and pick up that URL and take that update from that URL. And I believe that's maybe something what you find really simple, but that's good if you find it like that, because you will see a lot of talks about IoT platforms, and to see how easy it is to combine them with Akamai OTA service, I think it's a nice and good thing to know. Coming back to our presentation, but before we do that, I really would like to see if I can get the data now. Maybe something went wrong. I will have to check that afterwards. Sorry for that one.
I think the data's there. It's only one by one.
I will not comment on that one because I just tested it a few minutes before it started, but maybe I did something wrong which I'm missing here. Let's see, no data there, which I retrieve here. I don't know. Anyway, that's this point. We went through the live demo. So summary which I'd like to make is, I hope you have a good impression about how OTA can be used. I hope you have seen that it is something that can be automated, and for your use case, you can go on if you have Java or whatever language, as long as you can support REST APIs. I'm going to provide this demo jar file, so in case you like to play with it, and I'm going also to provide the Docker file in case you like just to, without having the need to install anything, just to use it inside the Docker file. The OTA product, like mentioned before, is something that has been launched officially today, what will be launched and what's already available. More information about it is available on our website. And the good thing I like to say is there's more to come, so that's just the start for us as Akamai. So we really like to build more services around IoT and hope that they will be helpfully if you are running an IoT initiative in the future, or maybe already by now. That's the end of my talk. Questions? Please. That's something I developed. Everybody can develop something. It's just a wrapper around our open APIs, which are RESTful APIs, which means they are, most of the time, they are really like spare parts. And because I'm already working with a customer in Germany which is using our not yet called OTA service, but it's OTA in its core, and we developed that together with him because he needed that kind of wrapper around to make it really easy for his use case.
So it's just using that.
Yeah, right. And Bosch is also considering to use the same jar file to do the stuff, which is nice. So it means 2 people already which find it quite interesting. But they could have done it by their own, don't get me wrong. It's just that we did it because we thought it's a good example to show how easy it is to use the OTA service.
What about the security aspect?
We can, that's a great question, by the way. I haven't done that, but you could normally use client certificates. You can also use something like a ticket system, which means each URL gets a certain ticket, which allows it to be only accessed if the ticket is valid. which is called sometimes also a token. And you can go even further and have, if you like, some kind of IPA whitelist. So there are many, many possibilities. That's all things which are already in the core of the Akamai platform. I didn't highlight them because I thought, depending on the audience which is here, I wasn't sure how many know Akamai and which deep. I wanted to highlight things which are really new and which makes OTA to be a little bit special in that case.
As part of this, obviously, the security solution, will there be any, like we have a PCI compliance and we have the other things?
All the things which, all the things which exist. But to be honest to you, what we see is that most of the people which are doing OTA, they are going with self-signed certificates because they have a clear understanding about the user base, the client. So they don't need to take care about if that certificate will be trusted or not. It means they decide which certificate will be trusted when they deploy their devices. Just for everybody, if you do an HTTPS connection, then there's some kind of thing what is called a server certificate. And if your client likes to trust that server certificate, normally that server certificate needs to be signed or created or trusted by a so-called public CR. And in our case, most of the time you will see that IoT environments don't need that because you know all the devices and you know all the servers. So there's no need to spend money on having, in addition, a public CR involved, which costs money. And maybe means also that you have certain requirements like certificate key needs to be rotated every 2 years. And in certain cases, we see that IoT projects have the need that the certificate doesn't get rotated so often.
The jar what you created is the any settings with, I don't know if it's an enhancement or something, but can you connect at a particular cipher?
I can connect to a particular cipher, but that's in the core of Java, so don't get me wrong, that comes with Java, and nothing I have done here.
We can apply a specific cipher suite to an OTA.
That's perfect, sorry, I didn't answer it correctly. Yeah, if you look at the Edge server doesn't have any issues with it to provide either a public CR or a third-party CR. That's also in the core of our platform, and we support that. So there's a lot of flexibility, and believe me, we have been gone through several projects. Oh, I think we are already late. I think we will finish here. So in case anybody has any further questions, we have an IoT booth at the first level, and I will be there, and please feel welcome to come over.